Okay, so just as a reminder, this first problem here, so we talked on Friday about you might be able to figure this out without a calculator, right? But if you did need a calculator and you did need that formula, there is a formula to help you out. So the formula is what we're going to start with because of the fact that we need the formula for the next problem. So you might be able to figure out, because basically you're looking at these two lengths and you're trying to find like what number is in between. So what number is directly in between 18 and 22? It's 20, right? But how could you find that number with the formula? So the formula looks like this. It's 18 plus 22 divided by 2 is equal to the mid-segment number. Okay? So if you're doing this in your calculator, just so you know for future reference, anytime you want to put this all in your calculator, if you want two things to be divided by 2, it needs to go in parentheses. Okay? So if you added those two together, you get 40. 40 divided by 2 is 20. So my mid-segment length is 20. Okay, that's easy peasy when there's just numbers, right? What if there's not numbers? Okay, so let's go over to this other one. And there is another way to do this. So there is a way to do it in your head a little bit, and that's fine. But I'm going to stick with the formula for this one, just so that you have the formula available for you if you absolutely need it. Okay, so here's what the formula looks like. The formula says to take the bases, so the first base plus the second base, add those two together. So you're going to take 17 plus your 7x minus 5 and divide that by 2. Okay, we're going to set this up in like a little bit of an equation, a little formula. So what does that equal? Should I simplify that and put that on the other side? No, we're actually going to put the number. So what number is your mid-segment? So this mid-segment number is what goes on the other side. Okay? So you're going to set it up as base 1 plus base 2 divided by 2 is equal to your mid-segment. Okay? I would, very first thing, this is just me, to get rid of the fractions, I'd get rid of this 2 just right away. So let's just times by 2 to get rid of that thing. So times by 2, here's what you've got. 17 plus 7x minus 5 is equal to 40. And then we'll solve it from there. So now our Algebra 1 kicks in, and we simplify and solve the problem. So I'm going to continue solving this on, and then as soon as we're done with this problem, we have an answer, because it just says to find x. These are the 3 problems that are similar to that on that actual homework worksheet, that 8.5 practice B. So we're going to take some time to do that as well. Okay, so 17 and then minus 5, I'll put those two together. So 7x plus 12 is equal to 40. I'll subtract 12 from both sides. So 40 minus 12 is 28. So x equals 4. Ta-da. Okay, so we've got that one down. So that was a little bit, it's a good reminder from Friday, but also kind of takes it to the next level. So if you take that worksheet that I gave you on Friday, you should have the first 7 done. It's okay if you don't, because 6 and 7, we just went over those. We'll flip it over to the back side, so 12, 13, and 14. We'll give you a few minutes to do that, and then we're going to jump right into our kites. Okay? Yeah, that's what you're going to do. So we got a decimal there for that one.
Okay.
Yeah.
Also, I maybe there's one problem I don't know. I might just try it because I don't get credit for it if you know what's the problem.
Oh, then you do it.
Oh, okay.
Ask questions if you Yeah. So just an FYI, because the question just came out. Did I do it right? If I got a decimal. Excuse me. So 12 is not a decimal. 13 is a decimal, and so is 14. 3.1. Yeah. Okay. So if you got a decimal, don't be afraid of that. If you got a decimal for those two, it's okay. Our kites. Okay, so I'm going back over to the notes packet here. And for our kites, we're going to start with the definition and start with the properties. You'll kind of see how many we have over on the board over there. I got it in orange. And I went ahead and wrote in the trapezoids. Again, it's kind of hard to see unless you're sitting over there a little bit closer. But tomorrow is when this wall is going to be a little bit more important, because what we're going to do is we're going to look at a shape, and we have to say, which one is it? What are we looking at, and why? And the why comes from the properties that you see up there. Okay, so your reasoning should be one of the following things you see on the wall there. Okay, so for kites, the definition of kites is a quadrilateral. Okay, so it's got to have 4 sides. That's the important part. With 2 pairs of consecutive, congruent sides. That's how you say that. If I asked you to mark which sides were congruent, you would probably be able to figure it out, right? So you can kind of tell which ones are about the same looking. You've all seen a kite before, so you know what kites look like. So that's how you say that, but this is how we mark it. Okay, so what does that get for us? So that's the definition. What does that get for us? Everything we do comes down to terms of triangles, okay? So if I were to split it this way, don't. Okay. If I were to split it this way, would this triangle and that triangle be congruent to each other? No, you got a little one and a big one, right? And they're not even similar to each other. They actually have nothing in common. So instead, when we split this, we're going to split it right down the middle. And this is kind of going to show us two properties in one picture. Okay, so when I actually put them up on the board, I'll put them separately, but in this picture, they kind of both come from the same set of triangles, so we'll put them both together. So the first thing you can see is these are congruent by side, 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 right? Because you got that reflexive side in the middle. So now that they're congruent, I can say anything I want, but the only thing I have left is angles. Okay, and that's the part that we're going to get from this picture, is a kite has one pair, there they are, of opposite angles congruent. And we're going to use this property a ton on that homework assignment that you were just working on. Okay, this is the one key piece of information you need to know for most of those problems that you're going to see on that worksheet. Okay, so we have one pair of opposite angles congruent to each other. Okay? Fun fact, okay, not exactly as interesting or as necessary, but the fun fact of the day is that this long diagonal is also an angle bisector. Okay? Because I've just marked the other angles. And what it shows is these two are congruent up here, so I cut these two into congruent parts, and I cut these two into two equal parts. So that's bisect. So this diagonal is also an angle bisector. I'm going to write that down in just a second. I'm going to write it down over here on this other picture, though. Okay, so you can see that in this picture. You won't get that a ton on your homework, but you can kind of see it there, and it actually is a property. So let's go over to this one. Okay, so I'm going to mark everything I already know. Okay, so I already know by the definition. I know this and this and this and this. Okay, I knew that by the definition. By what I just drew here with these angle markings, I know this angle is congruent to this angle, and I know this one is congruent to that one. And this is kind of the obvious, right? We've got this reflexive piece right there, but then we also have reflexive here. Okay, so the only thing I'm really trying to show you is that those triangles are congruent to each other. So you have two triangles at the top congruent to each other and two triangles at the bottom congruent to each other. Again, nice information, good to know. What does that do for us? The most important part, this is the same property that happens in a rhombus. So this property by itself does not make a rhombus, but it is true for a rhombus. What is true about these four angles right here? They have to be 90, right? They look like they're 90, right? And they are because they're congruent to each other. So we have perpendicular diagonals here. Okay, so we have perpendicular Okay, so the two major properties that you absolutely need to know and be able to look at are right there. Okay, well, I'm going to write on the side kind of like the other, like, that's nice to know kind of information, but those are the most important ones right there. The kite is kind of the shape of one, okay, the shape of one pair. So we have one pair of opposite angles congruent. You have one diagonal that is an angle bisector. You have one diagonal that actually bisects the other diagonal, because this, let me come up to 5 tick marks here. Those would also be congruent because my triangles are congruent. So the one piece of information that kind of encompasses all of those things, like this long diagonal right here, this long diagonal is an angle bisector and it's a segment bisector. So all I'm going to write is that the long diagonal bisects everything. It bisects everything in its path. So I'm just going to put the long diagonal, so this is interesting information. The long diagonal is a bisector. Okay. Now, could that actually become the short diagonal? Sure. If I made this a short, plumpy looking kite, it might end up to be shorter, but typically it is longer. And the other piece of like interesting information that happens, not essential for us to know, is we have two pairs of congruent triangles going on here. Okay. And this is a note to self for working on your homework. That's what's going to come next here. So those are two little pieces of information that are like, hey, this happens. It's not a particular property, but it happens because of the properties. But the last thing I want to write down here is, because this right here says perpendicular diagonals, it says that right there. That means you have 90 degrees. That means you have right triangles. That means you can use the Pythagorean Theorem and sine, cosine, tangent. Okay? So we talked about that with our other shapes, but I'm going to write it right here. Because you have perpendicular diagonals, that means you have right triangles, which means you can use Pythagorean Theorem and you can use trig, which is your sine, cosine, and tangent. So anytime you have right triangles, those two theorems, rules, are open to you. You can use them whenever. And we are going to use the Pythagorean Theorem quite a bit on the homework practice. Okay? Okay, so now that's what you need to know about kites. And we're going to flip to the next page and just practice these things. So we've got our calculator next to us, just because then the numbers are a little bit easier to work with. Okay? Okay. So these, the first one is the angle measures. The second one is with side lengths. So we'll get to each one individually. But with the angle measures, the number one thing you need to remember is that these two angles here, those two angles are equal to each other. Okay? So if this one is 124, then this one is 124. Okay? If you can remember that, that's pretty much the only thing you need to know. Is this a triangle? Should it add up to 180 degrees? So in a triangle, it's 360, right? Because it's a quadrilateral. So we're going to go 360, or we're going to go 124 plus 124 plus 32 plus x, right? The other angle, or you could even put k if you want to put k. All of those should add up to 360 because we're dealing with a quadrilateral. So 32. So we've got 280 degrees here. So 280 plus angle K is equal to 360. So I'll subtract that out. And I've got 80 degrees left over for angle K. Okay. That's one way I could ask you the question. I could also give you angle K an angle T, and you would have to come up with E and I, but they're the same, so you could label them both X and solve it that way. So that's the only two different things we can ask you dealing with those angle measures. Those are the two things you're going to see. Okay, let's look over at this other one dealing with the side lengths. So the side lengths here, it does specifically say, and this is going to get a little tricky. It says right here, write your answers in simplest radical form. That's going to be interesting. All right, here we go. So if we want to find the side lengths, this is where it comes into play that you have to know that these are right triangles. But if we're being honest, don't they kind of look like right triangles? Okay, so kind of go with your gut on that one a little bit. So we're going to use the Pythagorean Theorem. So we've got on this side this Ki side. So Ki is going to be 4 squared plus 2 squared. So that's 16 plus 4. Or if we just type that into our calculator, 4 squared plus 2 squared, right? Just type that in, and you get 20. So Ki is going to be the square root of 20. Now, when it says simplest radical form, that's not simplified, right? You've got to break that down if you can. If you can't, you get lucky and you just get to leave it. But because that has a 4 in it, I want to break that down into 4 and 5. So my actual answer for Ki is 2 radical 5. Now we get lucky here because we have pairs of congruent sides. So if this one is 2 radical 5, then so is this one. Okay, so you really only have to do this twice. So now we need to do IT or ET with 2 and 6. Okay, so if we go IT squared is equal to 2 squared plus 6 squared. And again, you can type that into your calculator if you need to, but remember the simplifying part, that's the part we have to do. So IT is the square root of, so 36 plus 4 is 40, which is 4 and 10. So IT is 2 radical 10. And that's something that we've been practicing for a while, so I kind of went through that quickly. But it's basically just that you need to know that you need to simplify your radical to get the answers. Why? To be honest, there's no reason why other than to just practice simplifying radicals again. Okay, this is just another place we can practice simplifying radicals, so why don't we? Okay? Okay, so that's all of our notes pieces. So we're going to take the rest of our time here. And so if you flip back to the front, you've got 8, 9, 10, and 11 are the problems that we just practiced. Okay? And then number 15. Okay? All right. Then I'm going to tell you that question number 17, okay, it's a good question, but you're not going to see anything like that on a test or a quiz. So 17, we're going to call that an extension question. And then number 18, you can cross that one out because, again, we won't be doing any proofs for quadrilaterals, especially on a test or a quiz. Okay? All right.